Example 2, write the function equation in the form y equals c to the x for the following graphs. So we've got two graphs to look at. I'm going to actually do the increasing one first. It's a little bit easier to look at first. So it's increasing as it goes left to right. What you're going to want to do is, if we consider some other graphs that we've drawn, whenever we're looking at the exponent x, anything to the exponent 1 is itself, is the base number. So if we're trying to find the base number, it's a good idea to look at where x equals 1. So where x equals 1, what is the y value? So when I look at this graph where x equals 1, the y value is 5. That's going to be my c value, or base number. So my equation is y equals 5 to the x. I can check it with another point. If I wanted to do a check and plug that in, 25 is the y value equals base number of 5, x value squared, and you'll see that yes, it's true, 25 equals 25. We're going to use a very similar strategy for a decreasing graph. Okay, the idea is looking at this. The problem is where x equals 1, what is the y value? Well, where x equals 1, the y value is a fraction, so you're doing some estimating. So it's easier to look at where x equals -1 and recognize that that is at 4. So that means that when x equals 1, it's going to be the reciprocal of that. Okay, we can compare it here. If this was 5, this is now going to be 1/5. Okay, so our equation is y equals 1/4 is my base number to the x. You need brackets around that because the exponent applies to the entire fraction, so the 1 and the 4. Again, you could do a quick check with that. If we have the point -2 and 16 right here, and we were to check that, 16 equals 1/4 to the -2, 16 equals, when we take the reciprocal, 4 squared, 16 equals 16, so yes, this is true.